Hi everyone, welcome to CodeTav Management Backend Engineering playlist. So today mainly we will discuss about the completable future internal chaining. So first of all, I want to say like uh, understanding the internal mechanics of the completable future is exactly what separates the basic asynchronous code from your senior level or high resilient architecture. So it is a fantastic concept to master, and especially when tackling some complex systems or breaking down the advanced concurrency concepts for others. So first let's look under the hood. So internal chaining. So first of all, I will discuss how the internal chaining actually works. Okay. So a completable future is nothing but a wrapper. Okay, for background thread. So it's like for the other machines or mechanics. This is also a state machine, you can say, which is acting as a promise. And there are specifically three states. One is pending, one is completed, and another is completed exceptionally. So when you chain the operations future dot then apply, then you were not pausing the current thread to wait. Instead, you were wiring up a callback graph. So the first of all there are some internal sequence of events. Okay, so the first one is the subscription, like the check-in process. So what is that? Suppose you walk up to the barista and say hey, for my coffee order, makes your you add some caramel. So after that, the barista first checks to see where your coffee is in the process. So that's the subscription process actually. Like when you call the then apply, the Java runtime checks the state of the original future. Okay. Next is immediate executions. So immediate execution means already done. So the barista looks down and says, "Oh, your coffee is actually already finished and sitting right here." So they immediately grab the caramel, squeeze it on top, and hand it to you. So no waiting required. Okay. So the thing is, if the original future is already completed, the chained function runs immediately. Okay, that's the immediate executions. So whenever your original future is totally completed, the chained function runs immediately, just after that. That's the case. Okay. Now, if you will see the next one, so the next topic is the callback stack. Like the next internal sequence is the callback stack. So what is this callback stack? So that is nothing but like still waiting. So the just before it, the immediate execution is the already done part. The callback stack is like still waiting part. Like the barista says, like the machine is still brewing your coffees, right? So since it's not ready yet, so they write add caramel on a sticky note and stick it to the order ticket. So if you come back a minute later and say also put a lid on it, like they stick another note on that ticket. So that's the callback stack. Like if your original future is still pending, then your chained function is pushed. Where it is getting pushed, that is to the internal stack of dependents. So those are stored inside the completable future object itself. Okay. So the next part is the trigger part. So what is that? That's the actual action part. So when the coffee finally finishes brewing, your brewing of your coffee is totally done. So after that, the barista, like the background thread, flips your order status to done. So your brewing is already done. That's the case. So they immediately look at your ticket and see the sticky notes and execute them. They add the caramel, put on the lead, and complete the job. So that's the trigger. So when the background thread finally finishes its work, so it flips the state to completed. So it then pops every chained function of its internal stack and executes them. Right. So the subscription part is your initial one, where your future, original future, need to check from the Java runtime. that what is the state of it. Immediate execution means the already done part. So like whenever your coffee is all like whenever your coffee is already finished and sitting right there, so they immediately grab the caramel and squeeze it on top. That's the case. Like whenever your original future is totally completed, the chain function runs immediately. Next is the callback stack. What is the like still waiting state? Like if the original future is still pending, so that's the difference. Like immediate execution, there the original future will check is already completed, but for the callback stack, it will check your original future is still pending. Okay, that's the difference between these two. Okay, so your chain function is pushed onto an internal stack of dependents and stored inside the completable future object itself. Okay, so that's the callback stack. The name, like you from the name, you can see like the stack, right? So it will be stored in the internal trigger stack. Okay, and the trigger, that's the actual action part. So when the background thread finally finishes its work, so it flips the state to completed, right? So now, one trap thing is like by default, if you are use like if you will use the supply async without specifying a thread pool, then Java by default it will use the fork join pool, common pool. Okay, so what is the case of that? This pool is sized based on your CPU cores. You have some like 2 core, 4 core, or multi-core CPU you have, right? So according to your CPU core, your pool size will be decided and is designed for CPU intensive tasks. So if you use it for your IO operations like the database calls or some REST API calls, then you will exhaust the pool and freeze your application. So always pass a custom executor for IO tasks. Just comment like if you know about the custom executor. If you'll know, if you don't know, then I will describe. Okay. So the next part is the extended chaining. Okay. So what is that? The extended chaining means like while then apply, like you know, right? The then apply or then compose. Those two are the like very interesting two methods actually. Then apply we basically use for the sequential transformation, and then compose we basically use for the sequential async operations. Okay, so those two are your daily drivers, real world backend workflows, and that requires handling parallel branches and terminal states. Okay, so the parallel combiner is the then combine, and the terminal consumers are then accept, then run. Okay, so you will use the then combine when like you need to trigger two asynchronous network calls at the same point of time, and you need to wait for both to finish and merge their results. Okay, so like here you can see I have initiated one method which is like fetch dashboard data. So there, if you will see like two things like profile future and the stats future, like the status of the future. Okay, that two processes started with two completable futures. So one is with profile future. There you can see like supply async has been initiated, and I have told you if you will use the supply async without specifying a thread pool, Java uses the fork join pools common pool. Okay, so here you have used the completable futures supply async, and through that, what we are doing, we are fetching the profile. Okay. After that, through the user stats, here also we are creating another object, and we are again we are doing with the we are using the supply async. Okay, and through that we are fetching the stats, right? And after that, like suppose you are using one credit card. Okay, so then through the credit card there is one cred API. Okay, they first of all they check like if anything is pending from your side, and another API will check your credit score. So two things will be processed parallelly through two different threads, and after checking those two things, your some finance will be processed. Okay, so here as well, like through like we have started two threads, and two threads are working on two separate things. One is fetching the profile future, and another one is fetching the stats future. And when those two things are done totally, then the dashboard future will combine them. So there we are using the then combine. Okay, so from that we will get the stats future and the profile and status. Okay, and then we will return those results, right? Then the terminal consumers. So for the terminal consumers, we mainly use the then accept and then run. So what are the functionalities of this? So basically you use these at the very end of your chain. So when you are done the processing of the data and just want to trigger a side effect or returning some results. Okay. So like suppose you want to use then accept, like when you will use then accept. So when the consumers want to consume the final results. So final results means like you want to save some data to a database, or you want to send some messages to the Kafka event or Kafka topics, right? So in that case, you will use the then accept. And when you will use the then run, so then run will be executed like it basically executes a piece of code but doesn't care about the result. Like suppose one process has been finished, okay, you want to log that process. So in that case, you will use the then run. So here you can see like we have one object user ID future. So there we are composing the through the fetch user order async. And there we are accepting like through that then accept. We are printing like successfully saved orders to cache or some database like that. And then run, like after accepting that, we are executing the then run. So whenever the data will be consumed to a database or some Kafka event or some cache. Okay. So after that, we will just execute a piece of code to log that process. Like workflow is completed. We want to emit some metrics. Okay. Like for the dashboard purpose, like you know about the observability side, right? So like in the observability, what is being done? So suppose some data got persisted. Now from the consumer side, they want to check like what data got persisted. So they want to check it from the observability data dashboard. So there you can check it from the lookup or BigQuery or something else. Okay. So from there you will, or the consumer will get to know that that data is persisted. We are okay. Okay. So that's the functionality of the then run. Okay. Now the next part is the scatter gather pattern. Like there we basically use the all of. So when you transition to a microservice architecture, you often need to hit five or six different services. Okay, so like that can be simultaneous, and like every microservice will not run synchronously or parallelly, right? So maybe you need to wait for another, like you need some response, and that response will come from another service. Like you are in service V, but before the response part of the service B, the one invocation required to the service A. And from the service A, some result, some JSON response or something will come up, and that will be ingested to your microservice B. Okay. So when that process will be done, so you need to wait for some time for all the process completion. Okay, before proceeding. So so before proceeding to the next step, we need to do all of, like we need to combine all those things. So through the completable future dot all of, we will fetch something from service A, fetch something from service B, fetch something from service C. And when all the tasks has been completed, then we will add like then run. But as those services, service B, service C, and some topics are required from the service A, some things are required from service B, and some things are required from service C. So to merge it up or to zipping up, we will use the completable future dot all of. So when all the tasks will be like in a proper zipped manner or something like in a merged manner, then we will execute the then run. And as we are using the then run, so that I have told you the terminal consumer. For the terminal consumer, we use the then run. So when then run will be executed, that means like all microservices respond successfully. Okay. So if you will use in your Saga design pattern uh, uh, like any complicated asynchronous process or something like that, there you can use that one where some service is dependent on other service. Okay, in that case, actually, we will use that. Now, for executing this much processes, some exceptions or some chaos can happen, right? So, how to handle that chaos? So, to handle that, we can use the exceptionally or handle methods. Okay, so like whenever any exception is thrown, like anywhere in your completable future chain, so the standard try catch block will not catch it. Like in our normal synchronous programs, we use the try catch block, right? But in case of asynchronous process, suppose one thread is in running state, one thread is in waiting state, one thread is in sleeping state. Many conditions will be there, right? In many states, threads can be available. You know from the thread life cycle, right? So, like whenever these things are happening in your asynchronous process, then through the try catch block, it cannot be happened. So that's why there some executor service will come into picture that I will discuss in the next lecture or something. But here, just you will remember that here through the normal try catch block, we cannot handle the exceptions. Okay, so the exception bypasses the remaining successful steps and propagates like straight to the end. So you must handle the exceptions functionally using the exceptionally method or some handle methods like that. So see here some completable future dot supply async. Here, if true, we are throwing some new runtime exceptions like database timeout. So then we are returning the success data. Then see, like then apply it, the data got transformed, and then we are using the exceptionally. Okay, and there's we are printing some error message or some through the get message. Okay, like fallback default method, like the fallback strategies. Okay, and then the accept, like then accept we have used. Okay, so in the next lecture, I may discuss about the then apply versus then compose. Okay, so till then, stay tuned. Okay.